Good morning, grade 9. How are you doing today? I hope you are fine. We're going to continue our revision. We're going to continue revising geometry. We stopped on the second lesson in chapter 10. So we stopped here on this point. Okay, we're going to discuss polygons. Okay. The center of a regular polygon is equidistant from the vertices. Equidistance means all the distance are equal from the center to the vertex. CE is equal to CD is equal to CH is equal to CG is equal to CF is equal to CE. They are all equal distance from the center to the vertex. From the center to the vertex. It is called equidistant. So all the distance are equal. That's why it's called equidistant. The apothem is the distance from the center to a side, not to the vertex, to a side, to the side, perpendicular on a side, like CB. CB is the apothem. The apothem is the distance from the center to a side. A central angle of a regular polygon has its vertex at the center and its sides pass through consecutive vertices. The central angle is like here angle CDCE or HCD or HCG or GCF or FCE. Its vertex is the center of the polygon. The vertex of the central angle is the center of the polygon. And the two sides of the angle are on a consecutive vertices. Each central angle measure of a regular anagon is 360 over n. N is the number of sides of the polygon that I have. So the central angle is 360 over n in the regular polygon, because in the regular polygon all these angles here are equal. So if I want to know only one angle, so this angle is 360 over the number of sides, so 360 over n. Okay, to find the area of a regular anagon with side length S and apothem A, divide it into n congruent isosceles triangles. N congruent isosceles triangles. If I want to find the area of a regular polygon, whatever the polygon its sides is, so I would call it n-gon. N means number of sides, n-gon. So I will divide it into n congruent isosceles triangles. Okay, girls? So this one here, let me show you. This is the first one, second one, third one, fourth one, and fifth one. Why? Because I have 1, 2, 3, 4, 5. This polygon has 5 sides. 1, 2, 3, 4, 5. 5 sides. So it will be divided into 5 isosceles triangles. Okay, what is the area of any triangle? The area of any triangle is half base multiplied by height. Half base multiplied by height. So if I get an area of one triangle, I can multiply it by the number of triangles that I have here. For example, this polygon is divided into 5 triangles, 5 congruent isosceles triangles, 5 congruent isosceles triangles. So if I get the area of one triangle, I can multiply it by the number of triangles the polygon is divided into, and so then I will get the area of the whole polygon, like here. Area of triangle is half A multiplied by S. A here is the apothem that we talked about. A here is the apothem that we talked about, which is CB, CB, and the base is FE. So the area here of the polygon is N. The whole polygon is N, which is the number of triangles that I divided the polygon into. I divided, for example, into 5, so I'm going to replace N by 5. So N multiplied by half A, S, half A multiplied by S. Okay? Area of any, parameter of any polygon is N multiplied by S, is N multiplied by S. Parameter of any polygon is N multiplied by a number of sides multiplied by the side itself. So here I have N, here I have N, and here I have S. So I can remove N and S, and I can replace them by P, which is the parameter. So I can get another formula for the area of the polygon, which is half AP, which is half the apothem multiplied by the parameter of the polygon. Again, I will explain this part. If I get a polygon and I divided the polygon, regular polygon means all its sides are equal and all its angles are equal. If I divide this polygon into according to its sides, if the polygon has 5 sides, so I'm going to divide the polygon into 5 congruent triangles. If the polygon is 6 sides, I'm going to divide it into 6 congruent triangles. If the polygon has 7 sides, so I'm going to divide the polygon into 7 congruent triangles. And I will get the area of one triangle from the 6 or from the 7 or from the 5. I will get the area of one of them. Then I'm going to multiply by the number of triangles. Then I'm going to multiply by the number of triangles. The number of triangles is the number of sides. Number of triangles is the number of sides. So when I get here the formula, I get it. Area is equal to N multiplied by half A S. A is the apothem that comes from the center perpendicular to a side. And S is the side of the polygon. I have a rule that says the parameter of the polygon is N multiplied by S. N multiplied by S, number of sides multiplied by the measure of each side. So I have here in the formula N and I have S. So N and S together, I will remove them and I will replace them by the parameter. So I got a new formula for the area, which is half AP, half the apothem multiplied by the parameter. Okay, then the area of a regular polygon, regular one, is P. Area of a regular polygon with the apothem A and parameter P is half AP. Let's solve an example for this one. Okay. Finding the area of a regular polygon. Find the area of each regular polygon round to the nearest tenth. I have here a regular hexagon with side length 6 meter. Hexagon means that this polygon has 6 sides. 6 sides. Hexagon means 6 sides. And each side length is 6 meter. So I want to get the area. Area is half AP. So first I have to get P and A. P is the parameter. The parameter is NS. The parameter is NS. P is equal to N multiplied by S. P is equal to N multiplied by S, which is equal to N number of sides of the polygon, which is 6, multiplied by the measure of each side, which is also 6, so it is equal to 36. So the parameter is equal to, P is equal to 36. Okay? Okay. So the hexagon can be divided into 6 equilateral triangles. 6 equilateral triangles with side length 6 meter. Okay, girls? So this hexagon can be divided into 6 equilateral triangles with side length 6 meter. Okay. When, according to the 30, 60, 90 triangle theorem, this theorem you studied in grade 8, 30-60 theorem. 30-60 theorem said that, let me draw it for you here. Okay, this is of course a right angle. Okay, the hypotenuse is 2 S and okay. If I have 30, 60, 90 triangle, it has a rule. The hypotenuse is 2S. The measure of the hypotenuse is 2S. The side that is corresponding to the 30 degree is S, and the side that is corresponding to the 60 degree is S root 3. Okay, girls? So, why I'm saying this? Because I want to get the measure of the apothem. Since the 6 triangles are equilateral, so the apothem here divides the side into 2 equal parts. This part is, since the side is 6, so this part is 3. And since the whole triangle is equilateral, so the small triangle that is formed here is a 30-60 triangle. So, and since it is a 30-60 triangle, this one is the hypotenuse, but I will not use it. This is 30, so it is S, and this is 60 degrees, so the side that is corresponding to the 60 degree is S root 3, which is 6 root, which is 3 root 3, because the S here is 3, so it is 3 root 3. So the apothem here is 3 root 3. So here I got P and I got A. So half 3 root 3 multiplied by 36, so it is equal to 54 root 3, approximately equal 93.5 meter squared. Okay, girls, so another example here, a regular pentagon with side length 8 inch. Okay, pentagon means 5 sides. So pentagon means 5. They want to get a regular pentagon with side. They want to get the area of this pentagon. To get the area, I must get the apothem, I must get the perimeter of it. So, perimeter is easy. Perimeter is equal to P is equal to N multiplied by S. N is equal to 5 multiplied by S, which is equal to 8, which is equal to 40. So we're done from this part. Okay, the hardest part always is to get the apothem. So step 1, draw the pentagon. Draw an isosceles triangle with its vertex at the center of the pentagon. Why isosceles? Because if I draw from here, from the center to the vertex, and from the center to the vertex a triangle, this is equidistant. Okay, equidistant. This from the vertex to the center and from the vertex to the center, they are equidistant. And it will form an equilateral triangle. It will form an isosceles triangle. This side is equal to this side. Okay, then after drawing this triangle with its vertex at the center of the pentagon, the central angle is 360 over 5. I want to get this angle, this one, the whole one. This one is called the central angle. What is the rule for getting the central angle? Is 360 divided by the number of sides of the polygon. This polygon is 5 sides, so 360 divided by 5 is equal to 72. Draw a segment that bisects the central angle and the side of the polygon to form a right triangle. So I will draw from here to here a line that will bisect the angle and will and the side of the polygon to form a right triangle. Okay, so now I bisect the angle. So 72 is divided into 2 equal angles. So each angle is equal to 36. Do you remember, girls, the tan, sine, cosine, and tan? So I will use the tan ratio to get the side here, the apothem. So I will use tan 36 is equal to opposite over adjacent. Opposite over adjacent. Opposite is 4 and adjacent is A, which is required. So A, which is the apothem, is equal to 4 over tan 36. That's why all the rules of the geometry are related and connected to each other. In this example, we used the tan ratio. In the previous example, we used the 30-60-90 triangle that you studied in grade 8. That's why all the geometry book is connected to each other. We can't say that we studied in grade 8, so we will forget about it. No, we studied in the first term in grade 9, we will forget about it. No, they are all connected to each other. Use the apothem and the given side length to find the area. Now I got the apothem and now I got the area. When I multiply half the apothem and the perimeter together, they will give me the area. Okay. If we go now to the next lesson was easy. It was completing figures, composite figures. Composite figure is made up of simple shapes such as triangles, rectangles, trapezoids, and circles. To find the area of a composite figure, find the areas of the simple shapes and then use the area addition postulate. So, if I have a composite shape, I will divide this shape into famous or popular shapes, simple shapes like this one. I can divide the shape here into two rectangles. I will get rectangle 1, then I will get the area of rectangle 2, then I will add the two areas together to find the area of the whole figure, the area of the composite figure. And here is the same. I have the whole purple figure. I will divide it into three figures, small simple figures, triangle and rectangle, and half a circle. Okay, girls, and I will get the area of each figure and I will add the three areas together. Okay, we studied in the first and second lesson how to get the area of the rectangle and the circle and the triangles and all of those. So it is easy now. When I can get the area of each simple figure, I will add them all to get the area of the whole composite figure. Like here, let's take the first two examples here. We divided this shape into two parts. This is 1 and this is 2, so I have to get the area of 1 and I have to get the area of 2. So the area of 1 is base multiplied by height, so 12 multiplied by 15, so it's 180. The second one I have is 27 and 9. I will multiply 27 and 9, so it will be 243, so I will add the two areas together to get the area of the whole figure. Another one here, half base multiplied by height, here the area of the triangle, but I don't have here the height. So how I will get it? I will get it by Pythagorean theorem. First of all, I have here the hypotenuse is 10.8 and this one all from here to here, all this one is 7.8 and the corresponding part here is 3. So from here to here is also 3. So what about this part? This part is 7.8 minus 3. 7.8 minus 3, which is equal to 4.8. So this part is equal to 4.8. Let me shade it in red. This part is equal to 4.8. So I know the 4.8 and I know the hypotenuse. 4.8 is the height. I want to know this part, the green one here. Because if I will know the green one here, I can get easily the area of the triangle and the area of the rectangle and the circle also. So how I will get it? I will get it by Pythagorean theorem. Hypotenuse squared is equal to the red squared plus the green squared. I know the hypotenuse, so I want to get the green. So the green squared is equal to the hypotenuse squared minus the red squared. So the hypotenuse squared, 10.2 squared minus 4.8 squared, their square root is equal to 9. So the green line is equal to 9. Okay, so I can get the area of the triangle, half base multiplied by height. The base is 9, the height is 4.8. So half 9 multiplied by 4.8 is 21.6. The area of the rectangle is 3 and 9 together. 3 multiplied by 9 is 27. What about the area of the circle? Is pi r squared. As I see here, I have the whole diameter. The whole diameter is 9. I want to get the radius. The radius is half the diameter, which is half 9, which is 4.5. So half pi multiplied by 4.5 squared. So I will get now the area of the circle. So now I got the area of the triangle, the area of the rectangle, and the area of the circle. When I add the three together, I will get the area of the whole figure. As you see, girls, it is easy to get the area of any composite figure by dividing it into simple figures, popular and famous figures like square, rectangle, triangle, and circle. By the way, here, girls, the area of the circle that I got here is the whole circle, and here I have half of the circle, so I will divide the area that I got for the circle by 2, because here I have half of the circle. I'm done for today, girls. I hope you got it, and thank you so much. See you tomorrow.